4.2, factoring quadratic equations. So you need page 156 in your workbook. We're going to go work through this together. Okay, there's something called the zero product property, and we've seen this before. If two numbers have a product of 0, then one or both of the factors must be equal to 0. So that's what they said here. If x times y equals 0, well, either x has to be 0 or y has to be 0. If the factors of a quadratic equation have a product of 0, then one or both of the factors must be equal. So now we've gone from just regular numbers to being a quadratic equation. So if we have two factors multiplying to be 0, either this first factor is 0, that factor is 0, or they're both 0. This is a great organizer, this first page, guys. Okay, if you need to solve a quadratic equation by factoring, step 1, you always must write it in ax squared plus bx squared plus c equals 0. You must move it over so that one side, the right side, is 0. Then we factor the left side. So here they factored the left side. Then you set each factor to 0. So those are the steps we're going to take whenever we're solving a quadratic equation by factoring. How to factor polynomials in quadratic form. So this is a polynomial. The word poly means many, nomial means number. So it's a polynomial because instead of just having an x squared or a y squared, we have x plus 3 all squared. So it says here we replace the expression with a variable. So instead of having x plus 3 and x plus 3 there, we're just going to put in, sometimes they call this a dummy variable. We're going to say let r equal x plus 3. And then it becomes this form, which is a lot easier to work with. Okay, then we're going to factor it. So they've gone through and they've factored, and then at the very end, once they have their factors, wherever they see r, they put in their x plus 3, which is what they started with. Okay? And then we simplify if we can. Okay, and the last thing we're going to look at is factoring a difference of squares. So you recognize a difference of squares because there's a perfect square subtracting a perfect square. So we have 25x squared minus 100. Well, the square root of 25x squared is 5x, so we put that in the first spot. Then we have minus 100 squared. The square root of minus 100y squared is 10y squared. So we put the 10 there and the 10 there. We add 1 and subtract 1. So there's a plus and a minus. Okay? Let's try this out. So we need to factor each of these. Let's look at A. X minus 16 squared minus 25y squared. So first of all, because it's only two terms, I'm always going to guess, I think this might be a difference of squares. And look, it says it is a difference of squares. The square root of x squared over 16 is equal to x over 4. Because we took the square root of both the top and the bottom. The square root of 25y squared is 5y. So they've said at the brackets there's a plus sign in one, a negative sign in the other. We put the square root of the first term here, x over 4, put it in the front spot of both of them, and then we put the square root of the second term in both spots, 25y and 25y. And here's the general form. This is nice here. How could you verify this is correct? Well, you could actually FOIL it out. Okay, the second one, 9 times x minus 1 squared minus 100 squared. Again, there's like two terms here, so it's probably going to be a difference of squares. Well, the square root of 9 times x minus 1 all squared is just 3 times x minus 1. And the square root of 100y squared is just 10y. So we're following that same pattern where we put the square root of the first term in the first spot in the brackets. And this was, they just filled in part of it. And then we put that second term, 10y, in the brackets. Again, we add 1 and we subtract 1 there. Okay? Simplify by using the distributive property. So they said, well, let's multiply that 3 there. So we get 3x minus 3 plus 10y. And over here, we also get 3x minus 3. Okay, minus 10y. Okay, C. This has 3 terms, so it cannot be a difference of squares. However, it might be a polynomial. It might have many. So what we're going to do, this is a quadratic in x plus 3. This means that you can view x plus 3 as a single variable. We're going to replace it with a variable such as a. So so what they did is they put, wherever they saw an x plus 3, they put a. So they said, well, let's just write a there, and let's just write a there. So what they really have is 4a squared plus 8a minus 5. So what they need to do is determine the two factors of negative 20 that have a sum of 8. So what two numbers multiply together to give you negative 20? And they got negative 20 because they said negative 5 times 4 is negative 20, and they add up to 8. Well, what are some factors of negative 20? We have 20 and 1, and one of them has to be negative. Well, that won't add up to 8. We have 10 and 2. Wait a second, that might work out. So 10 and 2, which one is negative? Because one has to be negative to give us our negative 20. Well, let's try positive 10 and negative 2. We're going to write this equation using these factors. So they expanded 8a to be negative 2a plus 10a, and then they factored by grouping. They said, okay, let's group them like that. Well, what's the biggest common factor that comes out of 4a squared minus 2a? Well, I can factor out a 2a. The biggest common factor between 10a and negative 5 is 5. I'm left with 2a minus 1. And because these are both the same factor, this can be written as 2a minus 1 times 2a plus 5. There's another way we can factor, and that is using that square process. So if you want me to show you that, just ask me to come over to your desk. We're going to replace a now with x minus 3, and they did not give me enough room here. Okay, so wherever we see a, we're going to go 2a was x plus 3 minus 1. That's our first factor. And our second factor is 2x plus 3 plus 5. So again, just wherever I saw a, I put in my x plus 3. And so now I need to distribute. So I get 2x plus 6 minus 1 is my first factor. And I get 2x plus 6 plus 5 is my second factor. Can I combine anything in these brackets? I sure can. 2x plus 5 and 2x plus 11. Okay, those are our two factors. If we expanded them out, we would get our original equation. We would get a form equivalent to our original equation there. Okay, now we're going to factor determine the roots, verify your solutions. So we're going to factor, because it equals 0, we're going to set both factors to be 0 and solve. The factors, this one, x squared plus 2x minus 24. I need two numbers that have a sum of 2, a sum of that middle term, and multiply to be positive 24. Well, let's look at the factors of 24. I have 24 and 1. That won't do it. I have 12 and 2. That won't do it either. I have 8 and 3. No. I have 6 and 4. Now 6 and 4 is going to work because that can give us 2. But which one's positive and which one's negative? I need a positive 2. So I'm going to have 6 and negative 4. Okay, so I write this as x plus 6 and x minus 4. So either x plus 6 is equal to 0 or x minus 4 is equal to 0. So either x must be negative 6 because negative 6 plus 6 is 0, or x is equal to 4 because negative 4 minus 4 is 0. Now we're going to check our solutions. So what they did is they actually checked that x squared plus 2x minus 24. They subbed in negative 6, and they did the math and they saw that that was 0. Now they're going to try it again for x equals 4. They subbed it in, so they have 4 squared and 2 times 4. Well, 4 squared is 16 plus 2 times 4. 16 plus 8 is 24. Minus 24 is equal to 0. The left side equals the right side, so we have verified this. Okay, this one we need to show that the factors of negative 210, oh, let's look back at the question actually. 6x squared minus 11x minus 35. So this is a pretty one where our a value, the value in front of the x squared, is not 1. So these are good ones to try factoring. Okay. The factors of negative 210 that have a sum of negative 11 are something and something. What are those somethings? So they have to multiply to be negative 210 and add to be negative 11. Well, first of all, I see that we have 21 and 10 is my most obvious one because there's a 0 there. Does that one work? Negative 21, positive 10, it does. Okay, and we could have started with negative 2, 10, and 1. Then we could have gone half of that. We could have gone 2, and half of 210 is 105. And we would have eventually gotten there, but usually when things end in a 0, I notice that one first. So we know that this is going to be negative 21, positive 10, so it adds up to be negative 11. Okay? So we can rewrite negative 11 as minus 21x plus 10x. So we're just rewriting negative 11 in a special way so that we can factor. So now we group them. 6x squared minus 21x. We can take out a 3x. We're left with 2x because 3x times 2x is 6x squared. 3x times minus 7 is negative 21. And here they told us they're going to factor to 5. Well, what's left is 2x minus 7. And notice since those two factors are the same, we can write this as 3x plus 5 and 2x minus 7. So 2x minus 5 is equal, 2x minus 7 rather. Oh, they wrote theirs in the opposite order. 2x minus 7 equals 0. So x must equal 7 halves. So what they did is they brought the 7 over. So they said 2x equals 7. They divided by 2. Or 3x plus 5 equals 0. So x must equal, bringing the 5 over, we get negative 5. Then dividing by 3, we get negative 5/3. Okay? Then they're going to go through and they're going to verify. And this is a good exercise for you to do to make sure that you can verify this, even though it's fractions. And those two indeed do work. Okay, I believe there's one more problem on here, but it's just very similar to the other one, so I'll get you to do this one on your own. I do want to try this tougher one here. Bobby is building a rectangular concrete patio. Her budget allows her to buy enough cement to fill an area of 48 meters squared at a depth of 3 inches. She wants the length of the patio to be 2 meters long than its width. Sketch a diagram, write the quadratic equation, and solve it. What are the dimensions? So here we already have our beautiful diagram. We said the width is 2 meters longer than its width. So we have width, the length is width plus 2. The area equals width times length, so it'd be W, this is the width, times the length, W minus W plus 2 rather. Okay, and the total area is 48 meters cubed. Okay, now we're going to expand and rearrange to make it equal 0. So when we expand, we get W squared plus 2W, and we brought that 48 over. This is what we get. Now we must factor it. So we need to get two numbers that multiply to be 48. So 2 factors of 48 that add to be 2. Well, 48 and 1 aren't going to do it. Half of 48 is 24 and 2. No, is 48 divisible by 3? Okay, I just brought out my calculator here. 48 is divisible by 3. This is what I'd be doing on my calculator. 16 and 3 won't give us 2. Is 48 divisible by 4? I believe it is. 4 and 12 won't give us what we want. Let's try 48 won't be divisible by 5. Let's try 6. 48 by 6 is 8. Well, 8 and 6 can give us 2, so we know that that's what it's going to be. We want a positive 2, so 8 is going to be positive, and 6 is going to be negative. So we have W plus 8, W minus 6. So either W plus 8, that's an 8 there, either W plus 8 equals 0 or W minus 6 equals 0. Well, in that case, W must be negative 8 or W must be positive 6. Okay, it says, why do you reject one of these solutions? Can you have a negative 8 width of something? No, not in real life. So we're going to reject this, and we are going to say the width is 6. Well, if it's 6 meters wide, then it must be 8 meters long. And somebody will say, oh, look, that 8 seemed to be right here. And that wasn't really a coincidence. It's kind of the way it works sometimes. Okay, so you guys have questions to try.